Yeah, so my name is Xu Hao. So I lead climate change related activities at Tencent. Yeah, so I apologies. The slides is all in Chinese, but I'll try to make the message clear in English. So I'll probably start by just introducing the overall thinking around climate change in Tencent. So we take climate change as one of the strategic issues. One of my other role is at the group level strategic development group to look at how climate change may impact all the business in Tencent, which we have various BUs. So as a result of that, we probably, if we look at climate change issues, we probably want to do two areas of things. As shown on this slide. On one side, we want to be carbon neutral as soon as possible, and we committed to do so by 2030. That covers the scope 1, 2, 3 of our emissions, so including our supply chain. We committed that by benchmarking all of our kind of global internet peer companies. The reason the title says without too much emission, why does Tencent care about climate change, is because in absolute values, actually our emission is rather limited. Our baseline emission in 2021 is a little less than 6 million ton CO2 equivalent, which is a little bit more than 1,600 megawatt coal-fired power plant, the annual emission of that unit. And China, if not 1,000, will probably have a few hundred of those units. So that actually makes us think, in addition to just being carbon neutral as soon as possible ourselves, what else we can do? And that's why in the bottom half of this slide, we say we probably can do three things. Number one, we have a lot of channel to actually connect with consumers, including probably most of the participants today. How can we promote and identify and promote and define what does it mean for a green and sustainable lifestyle? How can we incentivize more consumers to take action, to contribute and participate in the climate agenda? Number two is, as a technology company, how can we leverage our digital capabilities to help many of the industries to decarbonize, be more efficient? That's probably the second part. The third part is climate change really requires a lot of emerging new technology to be developed and also be scaled up almost at the same time. So we need speed and scale at the same time. So technology innovation is really important. Accelerated technology innovation is really important. And we want to see, okay, what can we do on that area? So that's why we set up SSV, and that's why we set up a carbon neutrality lab under SSV to look at how Tencent, beyond our own emissions, how can Tencent contribute? And today I just want to introduce probably two specific examples to showcase what we are actually doing. Number one is actually on how can digital technology help with the low carbon transition. So one of the areas that is really hot is so-called demand-side management or virtual power plant. And the reason behind it, so our hypothesis is actually in the energy transition where more and more solar and wind in the energy mix, actually flexibility become a scarce resource. Flexibility can come from various sources, but what is the cheapest scarcity energy flexibility integrate? Which make us think, for example, our data center. Our data center, in addition to put a solar panel on our roof, have energy storage, and build a microgrid in our campus, what else can we do? Then we look at the calculation tasks in our data center. So roughly speaking, there are calculation-intensive or CPU, GPU-intensive tasks, which we can actually hand out part of the I/O system to reduce energy. On the flip side, there are I/O really intensive calculation tasks that we can actually reduce the frequency of our CPU and GPUs. And there are also more and more machine learning and AI training tasks that are really intensive, but it can be split up and move around in different locations and different timescale, which means our data center traditionally is almost a flat line if you look at 24-hour energy load, but now it can be really a flexible resources. So last year, together with Intel, we published a white paper to showcase at least we have 10 to 15% of flexibility, electricity flexibility, virtually for free. And this year, we're piloting in some of our data centers to see how we can actually use that flexibility to interact with the grid. And then we want to make one step further is what else can we do using similar logic? One of the things, if we go to the industry, is the steel industry. The steel industry, so we're at the moment piloting with one of the steel company in Zhejiang province, actually based on what so-called short process, which means they didn't make steel out of iron ore, but they make steel out of scrap. So they the process is more or less like they use what they call electric arc furnace, which consume a lot of electricity to actually melt the scrap into liquid steel, and then they adjusted the chemistry, and then they make steel product out of that, which is also an electricity-intensive industry. And why is that important? Because China, at the moment, produce more than 1 billion ton of crude steel every year. At the moment, only 20% of them is made by short process, by electric arc furnace. But in the future, as China develops more and more short process steel making will be possible. By 2050, China will probably make 60–70% by electric arc furnace, which makes us think: can we make electric arc furnace more flexible while not interfering the production of the steel plant a lot? So we build I come from a consulting background, so we build the issue tree to see what are the key drivers of the energy load, and then basically we did some experiment for the past year with this steel plant. So what happens is, if you look at the whole process, there is always a bottleneck process which cannot be stopped. Otherwise, you're jeopardizing the production sequences. So for this particular plant, the continuous casting, which is the last process that's turning liquid steel to solid steel, to slabs. As long as continuous casting didn't stop, the only cost is actually temperature loss. So we make a digital interface. On the one side, it actually looks like a power plant to interact with the grid. On the other side of the digital interface, we actually basically looking at how the plant can manage their internal process without impacting the continuous casting unit. As a result of that, we found out at least 10% of the energy flexibility can be achieved without almost impacting the whole production system. And the only cost is energy loss, because sometimes you need make the electric arc furnace producing a little bit faster and slower. And the energy loss is 1 degree Celsius per minute. And the liquid steel is 1,500 degrees, which means it's really minimum. So it's virtually for free. So at the moment, for the time limit, or don't go to the detail, but if you look at the very top line is the continuous casting. As long as there are no gaps in the top line, we can move around processes at the bottom, which is electric arc furnace. AOD means chemistry adjustment equipment, so that we can, according to the energy need, the energy load of the local grid, we can speed up or reduce reduce the production pace so that we can provide flexibility to the grid. And they can actually earn additional revenues. And the revenue is actually pretty attractive because at some time of the day, you can sell the flexibility for 3 RMB per kilowatt hours, which is actually a good business. So I won't go into detail of that. So that's one example. The second example is how do we actually promote the low carbon technology innovation. We launched a program, what we call Carbon X, last year. The hypothesis behind that is when we look at how can we accelerate technology innovation in low carbon technology space, we think 3 things need to happen at the same time. Number one is we need technology innovation, which means more technology need to be researched in the research institution or universities and actually go into the industries. Number two, we need business models, which means there need to be more and more startups. And number three is probably unique to climate change is we also need market making because in many of the places the market doesn't exist. For example, in China, we don't have a holistic carbon price high enough yet that carbon reduction is actually a business, it's actually a market. So we designed the Carbon X program just to focus on the 3 things. So we have a Carbon X lab supporting a lot of universities to build pilot projects outside of their lab in the industries. We have a Carbon X accelerator to actually look at how can we help some of the startups. We also have a Carbon X infrastructure to do some basic market making things. One example is we actually set up a MRV center to analyze technically all kinds of technology can actually reduce carbon or avoid carbon emissions or actually what is the comparative carbon reduction potential is. So for the first year, we actually focusing on CCUS technology. Not because we prefer CCUS technology over other. You have to do one by one. And the importance of CCUS technology has been covered by the previous speakers. It's one of the kind of fundamental, one of the most needed technology if we're going to achieve net zero. And if we over emit and we need to compensate, then CCUS is also important, which we think is pretty successful. And this year we're gonna launch Carbon X 2.0, which we're gonna have a global program, and we're gonna cover additional technology groups. For example, long duration energy storage or hydrogen, right? So the very last, I just want to show some of the project, right? One of the project actually turn carbon dioxide into bricks, which means in the steel making process, in the slag, there are actually calcium compounds which are used as solvent in the steel making process. After that, the solvent can actually also absorb carbon dioxide and turning it back into calcium carbonate, which can be recycled into the steel making process. The second technology is for the sustainable aviation fuel. Traditionally, for the aviation fuel, the kerosene is actually made out of oil and gas. But now there are technology can electrolyze carbon dioxide into carbon monoxide coupled with green hydrogen. You can make sustainable aviation fuel out of it. The third technology is there are biological process, anaerobic digestions that eat carbon dioxide and turning it into different kind of chemicals, methanol, ethanol, glycol, and many others. Yeah. So and we make the message this way so that we also want to connect with consumers. So that's the third part I covered when we say what Carbon Neutrality Lab want to do. So this year we're also working with a lot of consumer brands to see can we take out some of the CCUS technologies not only out of the lab into the industries, but also into the hands of consumers. Can they produce apparels? Can they produce chemicals that are covers our daily use? Can they produce something that also help our transport? So basically make emerging low carbon technology closer to our daily life. So that's very briefly what we have been doing for the past 2-3 years. Thank you.